In our last part of section 1.4, we're going to solve equations by factoring. So this is just kind of a hodgepodge area where other equations have been lumped in. The key here is you need to do all these by factoring. So remember your factoring rules. Again, if you don't remember how to factor those trinomials, please go back to either Khan Academy or YouTube and search for factoring trinomials. You can also join me during my Zoom problem solving sessions on Wednesday nights, and that will work too. So. Okay, solving equations by factoring. In example 11, you already know how to solve certain quadratic equations by factoring. So next we're going to look at kinds of equations that can solve by factoring that are higher degree equations. So you'll notice the very first one is x to the third and x squared minus 20x. Why am I not going to do a substitution here? Because the middle exponent of 2 is not half of 3. So the substitution won't work here. What I am going to do instead is just go back to basic factoring rules. Is there something that I can pull out of all three terms? Well, yeah, all three terms have an x. So let's factor the x out first. That'll leave me with x squared plus x minus 20 is equal to 0. What's left in the parentheses is a quadratic. I know I can factor it further. There are factors of 20 that subtract to 1. So we'll have the x that is out in front. The quadratic that's on the inside is factoring into x plus 5 times x minus 4. Now that I've got it factored, we're going to set each of the factors to 0. The x out in front is equal to 0. The next factor of x plus 5 is equal to 0. And the next factor of x minus 4 is equal to 0. So I get x equal to 0. There's one solution. X equals a negative 5 is the next solution. And x equal to 4 is the final solution. So I get 3 solutions. So for this one, because it's a cubic, I'm going to get 3 solutions. And they're all real. No i's floating around. So in a solution set, that would be negative 5, 0, and 4. And the little braces simply say that's a solution set. And when you're doing the online homework, it already puts those brackets or braces in there for you, so you don't have to do that. I tend to put them in numerical order just because that's how the online homework likes to see them. That's up to you whether or not you do that. So, okay, let's do another one. Slightly different, though. So example 12. We have 3x cubed plus 12x is equal to 5x squared plus 20. Okay, so this again has got a third degree. It's not quadratic in form because we've got 4 terms here. I do want all those terms on the same side, so I'm going to go ahead and move everything over and set it equal to 0. We'll do that anytime that we have something that is not linear. If you have exponents, move everything over. So I'm going to put them in descending order. So I'm going to keep the 3x cubed as the first term. When I bring over the 5x squared, it will become negative, and I'm going to put it next. I'm going to keep the 12x as term 3, and then I'll bring over the 20, make it negative equal to 0. So now they're in descending order. X cubed, x squared, x, and then x to the 0 or no x, basically. This time we're going to notice we have 4 terms. And anytime I have 4 terms, I'm going to try grouping. So let's walk through grouping as we do this. Grouping says cut it in half. So I like to draw a little line through it that cuts it into 2 terms and 2 terms. Notice that when I did it before that middle sign. Okay, I'm going to pull out an x squared from the first 2 terms. That'll leave me with 3x minus 5. So I take a look at the first 2 terms. I pull out anything they have in common. They have an x squared in common. I'm going to bring down my middle sign, which is a plus. Then I'm going to pull something out of the next 2 terms. Well, 12x and 20 both have a 4 in common. 12x divided by 4 is going to leave me with 3x. And 20 divided by 4 is going to leave me with a minus 5. That negative 20 divided by the positive 4 leaves me with the negative 5. Okay, let's go through that again. So to group, I'm going to cut it in half. I'm going to factor something in common from the first 2 terms. In this case, that was x squared. When I pull out the x squared, I'll be left with 3x minus 5. I bring down my sign, which is a plus. Then I take a look at the next 2 terms. They have a 4 in common. I'm going to factor out that 4, leaving me with 3x minus 5. What we're going to notice is the sets of parentheses are the same. And if you're using grouping, that should always be true for it to work. Now what we're going to do is pull out 3x minus 5. What's left over is this x squared and this positive. And I factored it using grouping. We're going to set each factor equal to 0. So up here, we're going to get 3x is equal to 5 from the first factor, and x is equal to 5/3. From this one, we'll get x squared equals a negative 4. We would square root both sides. This is going to be non-real because it's the square root of a negative 4. And again, in section 1.4, they only want the real solutions. So the plus or minus 2i that would come from over here is not part of the solution set. So we only got the one solution at 5/3. And that's grouping. Let's try a couple more examples with grouping. It's mainly because you don't use it very often. I want to make sure you can do it. So example 13. We have x to the third minus 3x squared minus x plus 3 is equal to 0. So 4 terms. That's my clue that I'm grouping. We're going to cut it in half, which would be right here. And again, it's before that middle sign. From the first 2 terms, we're going to pull out an x squared. That's going to leave me with x minus 3. From the next 2 terms, well, they have nothing in common. I need to bring down the sign, which is a negative. And because they have nothing in common, I'm going to pull out a 1. Now, in general, we usually don't write those ones when we have things like that, but we need it here as a placeholder. So I'm going to write that 1. So I'm taking negative x, I'm pulling out a negative 1. That's going to leave me with a positive x. I have a positive 3, I'm dividing out or pulling out a negative 1. That's going to change its sign to minus 3. That's why it's so important you bring down that sign is to help us with the signs. You'll notice that these guys are identical. So once you pulled out from both halves, the sets of parentheses will be the same. Because they're the same, we're going to pull them out in front. Left over is the x squared minus 1. We'll set each factor to 0. So x minus 3 to 0 gives me a value of 3 as a solution. X squared minus 1 equal to 0 is going to give me x squared equal to 1. This time I can square root both sides without having any issues. And the square root of 1 is 1, but don't forget your plus or minus. Sure turns out, and we'll see in a later chapter, that if we have a polynomial and the largest exponent, it's going to tell us how many solutions we should get, all solutions. So we have 3 and 2 more of them here. So here's 1 solution, here's 2 more solutions. So sure enough, we get 3, which is what I would predict, but that's later. We'll worry about that later. And that's grouping. And then finally, just to go back to just regular factoring techniques, let's do one more. We're going to do an x to the 4th. So this is our final example. We want to solve x to the 4th minus x squared is equal to 0. That's a little soft. That's 2. Okay, this is not 4 terms, so I'm not going to use grouping. I'm just going to use regular factoring techniques. And what that means is for this particular example, we're going to pull out what they have in common. So both x to the 4th and x squared have an x squared in common. That'll leave me with x squared minus 1. Setting factors to 0, x squared equals 0, x squared minus 1 equals 0. If you square root both terms over here, you get plus or minus 0, which doesn't really exist. So it's 0. It is a repeated root. So 0 appears twice, and that's coming from that exponent of 2. Over here, x squared will be equal to 1 again, and we just saw that when we square root both sides, we'll get plus or minus 1. So I do have 4 solutions sitting here that's being predicted by that 4. I have positive 1, I have negative 1, I have 0 and 0. If you were to write them all out to see all 4 of them, you have negative 1, you have 0, you have 0, and positive 1. There's the 4 solutions. We don't ever write it like that, but there it is. Yeah, that's everything that's in section 1.4. You should now be able to solve most of the equations that I would throw at you in this first chapter.